Hello there and welcome to this system design mock interview. Today we want to show you a really high quality, best in class system design answer so that you can use it to prepare for your interviews and use it to know exactly what standard you should be aiming for. With us to give us the answer as the candidate today, I have a former engineering manager at Google. It's Mark. Mark, how are you doing?
I'm doing great, Tom. Thanks for having me. I'm looking forward to doing this.
Oh, thanks for coming on. It's great to have you. Before we get started, just want to quickly give people an idea of your background as an engineering manager.
Yeah, I was an engineering manager at Google for 13 years and worked on several large-scale systems with lots of great engineers. And so I hope I've learned a little bit from them. And it'll be interesting to see me on the other side of the fence of being the interview candidate here. So I'm looking forward to it.
I'm sure you do a great job. And Mark also is a coach on our platform. So if you need some expert feedback ahead of your interview at Google, Facebook, anywhere, any tech company, then do check him out on our platform. Okay, if you're ready, Mark, let's crack straight into it. The question I want to ask you today is, how would you design Spotify?
Okay. So Spotify, probably one of the most popular music streaming services out there, I guess. Let me think about that just for a moment. Because there's a lot of aspects to Spotify here. Let me see if I can actually, maybe I'll just take some notes here so that I can kind of think through this, if that's okay, and kind of get some, make some assumptions. So I have some notes. I'll just put this right in here. And then if it's okay, I'll just use this for notes as well as sort of design diagrams and things like that later on.
Yeah, sounds good.
So let's talk about just some different, Spotify. Okay. So for Spotify, I can think of things. I mean, obviously there's songs, music, that's the main thing. There's, you have playlists. I mean, there's users, there's artists. I guess Spotify even has things like podcasts that, you can listen to and things like that. So there's a lot to it. And so in terms of the system design for today, is there like, can we constrain this a little bit just so that we can actually get through a design? What would be good to focus on here?
Yeah, let's constrain it. Let's limit ourselves let's look at finding and playing music.
Okay. So let me, use cases, finding and playing music. I'm just going to write it down like verbatim here. Great.
Yeah, I think that'll give us enough to talk about.
I think so. Yeah. Okay, good. So if I think about that, let me try and ask a little bit or think a little bit about the use cases a little bit more. So my typical use case then as a user, if I'm signed up to Spotify and I have an app on a phone, I am going to browse some music. Maybe I'll find a particular search for a particular song, but then the most core thing is that I play a song and it's coming back through my phone, maybe my car or wherever I might be, headphones to listen to it.
With big, broad questions like this, you need to constrain the problem, make it solvable in the space of an hour. And Mark did this well, establishing the use cases we wanted to focus on. If you're asked to design an already existing system, in this case Spotify, share what you know about it with the interviewer. They can correct you or fill you in if you have any knowledge gaps.
So if I think about if I think about metrics here, let's think about size. Let's do some quick drilling down into some numbers here. And pardon me while I get this going here. So numbers. So tell me about how many users you're thinking about here for this design.
Yeah, let's say 1 billion users.
Okay, 1 billion users. Okay. What about number of songs?
Yeah, I think I saw I think I saw somewhere that Spotify has about 80 million songs, but let's say we need to have capacity for 100 million on there.
Okay. All right. So 100 million songs, billion users, and we're going to focus on the song piece of it. So, but let me do a little bit of math here, or a little bit of thinking, and I'll just double check with you to make sure that this makes sense. But from what I think about a typical MP3 audio is going to be about, for a typical song, is about 5 megabytes. And I mean, I think that depends on the encoding of the song, how long the song is, and things like that. But if that's okay, we can just kind of make that assumption. Is that fair?
Yeah, that sounds good to me. Mm-hmm.
Yeah, I mean, I think you can encode these things in, really low quality, like 96 kilobits per second, all the way up to 320 kilobits. But right in the middle, 128, 160 is maybe about that. So, all right. So let's assume that. And so then let me just extrapolate from this. So you got 5 megabytes per song. You've got 100 million songs. So I think that translates to, I'm trying to do my math here. So 100 million would be going to 1,000 times, that would be 100 billion. And then 100 trillion would be 1,000,000 times. Times 5 would be 500 trillion. So we're talking about total audio is something like 500 terabytes, which is, I guess it's the same thing as half a petabyte of data. And so I'm making that assumption. And so then, depending on how you replicate this data, because you typically want to have these songs in have multiple copies of these things so they don't get lost, et cetera. And if some replica is down, so, maybe you do, let's say, my keyboard here, 3x replication. So that would mean like 1.5 petabytes of raw audio data. And then each song, in terms of the metadata, meaning the song title and things like that, and artist and all these things, the metadata is probably not very big. It might be, I don't know, 100 bytes per song or something like that, per song of metadata. And so you might wind up with, okay, so let me do then that's billion, 10 billion. So that's only 10 gigabytes of song metadata. It's not really very much. And even if you say it's a kilobyte, then that's 100 gigabytes. So it's not very much. And let me just double check my math here. 100 million times 100 bytes. Yeah, I think that would be 10 gigabytes. So even if we rounded up dramatically and said 100 gigabytes, that's just not a ton of data. Now, in terms of user data, you might have, again, maybe you have a kilobyte per user metadata. I guess it's all metadata. And so that might be times 1 billion users. So that would be a terabyte of data approximately. So just to so this is just me doing some quick metrics, quick calculations to get a rough back of the envelope of how big these things are. So does that make sense so far? Does that seem?
Yeah, that all makes sense so far. Before starting your high-level design, as Mark did, get some metrics to help you identify any high-level decisions that might be influenced by the scale of the system. Mark asked the right questions about the number of users and number of songs, and made some rough calculations without getting bogged down in the numbers. What Mark didn't calculate was the traffic, how many songs are streamed per day, or per second even, and that would have helped him figure out the scaling of the web servers, how many he'd need and how much bandwidth he'd need. However, since this didn't impact his high-level design, it was okay not to go into the details of scaling at this point.
Okay, so let me maybe think about some basic components here, and I'm going to draw them, but I'll get into them maybe a little bit more in detail later. So some basic components that I would see. So let me start with something that is my best attempt at a mobile phone here. So you got your Spotify app, and I'm going to make this smaller so it fits into the thing. So you've got your app, which is on your phone typically, and I'm going to assume here that we're talking about the phone app because that's very common. And so you've got your phone. The phone is going to be talking to an application server, a Spotify application server somewhere, or a web server, I guess. And so let's draw some. Let me just put like over here, just say there's a Spotify web server, and there's not going to just be one. There's going to be lots of them, and assume that that's lots. And then, of course, just because this is a standard thing that you do when you have applications, in the cloud here, this is, I guess, part of the cloud, you've got a load balancer. And so let's assume that we've got an arrow here that's talking, so Spotify app's talking through the load balancer ultimately to these web servers. And so those are some sort of key components here. Let me think about this a little bit further. Yeah, I think that's good so far. Okay, and then of course, the most important thing, or one of the most important things here, let me see if I can find I know that there's a shape here. Here we go. That's a good shape. I'm just going to call this the database. And let me make this a little bit more. Let's see, that's what I wanted. Okay, so there's a database, and so the web servers are going to be talking to the database and getting stuff from basically writing information to and from the data, reading and writing information to and from the database. So those are kind of the very high level components.
In system design interviews, good dual bandwidth communication is important. That's to say, you need to communicate well via both drawing and speaking. You should practice this thoroughly before your interview. Mark did this well. He started drawing the components quite early on in his answer, and this allowed the interviewer to follow along easily. It's okay to have simpler and fewer components at this point in the interview. You can then break it out later in your answer, as Mark did when he split his database in two.
And I probably am thinking about this. I think this is obviously oversimplified, and I'm not going to redesign Spotify, the existing full application as it exists, but I do think I can get a little bit more detailed here I'm thinking about the data again, because the data is important. So I'm thinking about the metadata and the user data and the audio data. And they're very different types of data. So I'm going to split this database here into two things, and I'll explain that, or I'll try to explain it just a little bit. Come on. There we go. Make this just a little bit more. So I'm going to split this up and say that there's a song audio database. And then there's going to be a metadata database. So this is users, songs, what else? Art. Ultimately, there would probably be artists and et cetera, things like that. But we're focusing on the songs, I think, in the music. And so, this is also a database, of course, song audio database and metadata. And so I think, let me make this a little bit more, this Spotify web server is actually going to talk to the metadata and the audio database. So it's actually going to be talking to two databases here.
Okay. Yeah, that's interesting. Can you go into a bit more detail about why you'd split them into two?
Yeah. I'm kind of making that, just assuming that or making that. Yeah. So, okay, let me I want to answer. Let me try and think of this in terms of the technologies that I might use. I might use something like Amazon S3 here, and I might use Amazon RDS. And so now let me explain what I mean by that. So the type of data, the actual MP3 files, those I think of as immutable data. They're just blobs of data. They're files. They're 5 megabyte roughly on average files. And they're not going to change. They're just being streamed. They're being, stored and streamed essentially. And so a blob database, which is what S3 is, lends itself really well towards that. And it could be something like Google Drive, or there's other, technologies that are sort of just document like blob storage systems. But Amazon S3 lends itself really well to that, and it scales greatly. You can just add more and more and more and more, and it scales linearly, which is great. And then you can connect it up to be able to stream the data and things like that. So that type of data and the access patterns for that, which is really mostly read, you're just streaming this data. You're never going back and forth and writing to it. That would be why I would want to put the songs in that kind of a database. Now, S3 is great for that, works really well, but the data, the metadata, which is the users and their information and the songs and their information, and maybe they get updated, maybe you're searching across them and having to do queries to find songs for a particular genre or artist or things like that, or you're trying to update your users. Like if I'm playing a song and I want to remember where I left off so that when I continue playing it remembers that, I'm going to be modifying the data quite a bit, or going back and forth between that database and doing these queries. And you can't really do queries over S3, but you can over like a relational database. So MySQL would be another option. I just chose RDS here, Amazon's relational database as a because I'm going with the AWS family here. But yeah, so let me try and just write something here a little bit more in terms of songs. You would have things like a song ID. You would have a song, maybe a URL like that you would use for sharing. You would have an artist, a genre. Maybe there's a link to album cover, and maybe there's the link to the audio, I guess. So this is too big to fit. So this is the type of data that would be stored in. Let me draw this in here again, like in that database, and then just the raw. I mean, I almost don't need to write this here. So song MP3 would be stored in this database down here. So so I think that the access patterns, the types of things that you want to do, the size of the data, because the size of the data here, I think we said was going to be, half a petabyte in one for one replica. So S3 lends itself well to that. The data here is going to be, in the maybe a terabyte range, something like that, and it's going to have lots of queries over it, maybe some updates and things like that. So that's why I would separate these out, is because I think the access patterns, the size of the data, and the type of queries that you need to be able to do over would be very different. Does that make sense?
Yeah.
Does that answer?
Yeah, it does. Thank you. Yeah, I think that makes sense. At this point of your answer, when you've laid out the main components, it's good to start identifying some technologies, as Mark did here, starting with the database. His design made sense, breaking up the databases into audio data and metadata, but he could have explained why he was doing this up front, rather than waiting for the interviewer to ask why. In general, try to be upfront about your decision making. Yeah, feel free to continue.
So let's say we have these two databases, and I'm just trying to think about now the actual the use cases we talked about. So finding and playing music. So for finding music, I think the Spotify app, would need to request do a find music. And so the user probably, either is typing in like an artist name, or maybe they're selecting a bunch of filters. I'm not that familiar with that's how possible that is. But let's say I'm searching for music for an artist with a particular genre. And so ultimately somehow I'm filling in this query in my app, either by clicking on some things or typing some things or a combination. And then that request to find music is going to be sent to this web server, going through the load balancer, pick a web server, it's going to go there. And then that web server is going to do a query, issue a query, translated query to the relational database to find a bunch of songs and return a list of songs, and return that back up to the app with whatever metadata there is. And let's say that I found it finds, I don't know, 100 songs that match my request for Korean pop music or something like that. And so I now get back 100 songs, and I can look at those. And now, once I've gotten that list of songs, and by the way, for that query where I'm searching for music, I don't touch the MP3s at all. I don't need to go to that database at all. I just need to go to the metadata database and do this query. And because it's a relational database, that query can happen pretty efficiently, et cetera. So now I return that information back, and then I display that to the user. Does that make sense in terms of finding music?
Yeah, that makes sense. That's good.
Okay, and so now I have a list of songs, and maybe there's like one of the ones in that list is like, oh yeah, that's the one I was looking for, and so I click on that song to play it. I want to hear the song. So that's that second sort of part of the use case that we talked about, which is playing music. So now to play music, now this gets a little interesting, and this is I think I'm going to wind up maybe changing what I'm thinking about here a little bit, but let me just talk through it. So I click on the play button, or I click on the song to play it, and that translates into a request from the app to the web server to start playing the song, and it has an ID, like I mentioned, has like an ID in it. And so now the web server, based on that song information ID, maybe has to go to this database here to look up the link. What did I call it? Oh, an audio link. Maybe that's an MP3 link. I don't know, something like that. Maybe that's a better term for it. I don't know. So the MP3 link, and so that MP3 link or audio link would be returned. And now the Spotify web server has to go to the database where the actual audio is stored and fetch that database. Now, you could imagine streaming that 5 megabytes from this database. So chunk by chunk, it comes back, and chunk by chunk, it goes up to the Spotify app. In order to do this, you need like a WebSocket connection. So you need a kind of a long-standing connection between the application and this web server, so that you can send the data back in chunks. But I'm not sure whether I would need to do that, or whether, because it's only 5 megabytes, that's possibly small enough to just fit in memory, read from from S3 and fit into memory, and then have that particular web server chunk it back from there. I think that might be better, because it would eliminate the possible lag between the database. So you don't start streaming the audio until you have it in memory. That might be something that I would consider doing. So now let me think about. So that would be. Does that make sense in terms of like the playing? Like you start playing, and now obviously you can control it. You can pause playing and so on. But does that make sense? So you start playing. The web server gets the request to play. It maybe gets the information about where to go over here to get the S3 storage, audio storage, reads that back. It's only 5 megabytes. That should be almost instantaneous. And then it starts streaming that back to the application. Does that make sense?
Yeah, that makes sense. Please carry on. Yeah, it's all good so far.
Okay, so this almost sounds too good to be true, or sounds too easy. I think there's got to be more complicated than that. Okay, so one thing I'm just realizing here is probably out of these, what did we say? We said 100 million songs. There's probably a lot of stuff that is, I'm going to use the term indie artists or something like that, stuff that few people, not very many people listen to, or isn't very popular. And on the flip side of that, I'm thinking about like what could go wrong here. Well, if like BTS, which is again a Korean pop band, if let's say they release a new song, and it's like, hey, everybody wants to listen to this. This is super. Oh, have you heard the latest song, etc. If you've got all of these web servers all fetching that same thing, that same song, and let's say you've got requests like it's released, and in the next minute you've got, I don't know, you said 1 billion users? Okay, let's say that 10 million users all request the song all at the same time or something like that because it's just been released and they're following, social media or something. You could easily overload in terms of bottlenecks. You could overload possibly that bucket or not bucket, excuse me, that particular song, that file or whatever, however it's stored in AWS, and it could be stored different ways. I'm using S3 here. You could overload AWS or S3 there, and you could also possibly be, like streaming, like loading up all of these web servers with the same song, streaming the same thing back. So it's a lot of bandwidth, etc. So a better thing to do, and a common thing to do for stuff like this, is to use what's called a CDN, content delivery network, which is it's a cache. So this helps reduce the amount of load on backends. So let me draw something here. I am going to pick, what shape am I going to pick? I'll just pick randomly something like this. So maybe over here. So I'm going to say here, this is a CDN, which is an song audio cache. This is typing in. And so what would happen? So, and by the way, the technologies here, this CDN, a content delivery network, is usually very, very close in terms of number of hops and network connections to users. So what would happen is, let me draw another arrow here, and let me draw an arrow down to here. So what would happen here is that the first time that this song, this new BTS newly released single is requested, the web server would read it and stream it like normal. But probably we need to make sure that these Spotify web servers are somewhat, they're keeping track of things. And they're keeping track of, which songs are being requested, which ones are hot. They probably have a heat map, the most recently requested songs. And so in that heat map, as they see, oh, this song is now, I've seen this requested the third time in a minute or something like that. At that point in time, what it might do is it might actually, instead of just streaming it back to itself or copying it back to itself, it might actually load that into the CDN. And so I'm going to have to draw another arrow, I think, in order to do that, because these things probably have to talk to the CDN. And by the way, I'm not a super expert on this area in terms of how this works, but there's some connection between this edge caching, this content delivery network, which is just there for caching, and these Spotify web servers. So these web servers are going to somehow notify the CDN, hey, you should be pulling this song, this BTS latest song, pull that from the MP3, the audio storage. So the CDN, would load that up, and this now has to work in conjunction with the application. So that means that the application, when the person decides, when I request a song, I want to play this latest BTS song, and I haven't had it on my phone yet. It's just been released. Before I go and I talk to the web server, I might even go and check the application might actually go and check in this content delivery network to see is it there. It might also be so, and if it is there, then I just read it from there. The other option, the other possibility, and again, this is technology that I'm sort of not super familiar with, is that it goes and asks the web server just like it normally would, and the web server sends back a redirect saying, hey, I don't have it, but you should go over here to this content delivery network, this edge cache, to fetch the song. It's much closer to you. You'll get better performance, and you won't be loading me up so much. So I've got a lot of arrows here, but the standard flow for a song first time around is, coming around, getting the metadata, going around to reading the audio data. The web server is now keeping track and realizing, oh, you know what, I'm getting multiple requests for this same song. Now I'm going to tell the CDN, go and fetch this song. It's going to fetch it. And so now the application can be redirected, for example, to read that audio from there. So that's a lot of talking, but I was realizing that caching here seems like it's a very important point in this design, and would help with the bottleneck of hot songs, if you will. Is that
absolutely? Yeah, that's.
And by the way,
that's a really good answer.
Okay, and there's again in the AWS family here. I'm going to use the family. Obviously, if I were at Google or I might not be using this, but there's a technology called CloudFront, and CloudFront is basically a content delivery network. There's a bunch of other ones. Flask, is that what it is? I can't remember what the names of these technologies are, but there's a bunch of other technologies that are very similar in nature that allow you to do this. So that would help with the bottlenecks. And in terms of the caching here, you could also, and this is part of the reason, by the way, I just stepping backwards here a little bit. Part of the reason why I think it would be better initially when the web server is getting the song for the first time, for it to read the entire MP3 into its memory, because then if it is getting multiple requests for a particular song, then it doesn't have to go to the database. It can actually just feed it from its memory, and that's also a form of caching, of course. So it's got a local cache essentially of these songs, and you could imagine having a shared cache that's shared across these web servers. So that could be another optimization. But my point is that if we have a cache in memory in these web servers that stores the songs, then we're offloading the database a little bit. If we then have the cache here at the edge of the network, so that's what it's called, edge caching, then we're offloading the web servers to a large extent, because the streaming, this is optimized for streaming and so on. And I think if we go one step further, actually, I'm sure, and if I were designing it, I would design the application, because these are on smartphones, to store the songs that are played frequently by the specific user locally in the local storage. So it's another form of caching. So then, if it finds the song in its local cache, essentially local store here on the phone, then you wouldn't even need to go to the network at all, right? So you could actually, I'll even draw it like this. So it's like a little cache, little local storage here of songs. So there's multi-layer caching, I guess what I'm saying. Multiple levels of caching, ultimately with the goal to provide the best user experience, make sure it's super fast, and to then offload, obviously, the system to allow it to sort of scale and limit costs, et cetera. So that's probably enough on caching. And I think I've gone deep a little bit there.
Be ready for the interviewer to ask you about particular components or different aspects of your system, and to talk in detail about them. It's also good to talk through the flow of a particular use case. This helps make sure the interviewer is clear on it, but also helps you test your design as you talk through it, as well as helping you identify any potential bottlenecks, as it did with Mark here. Mark explained the purpose of the caching and also where caches might exist in the system. Caching wasn't limited to the CDN and the app, but also the web server. he could have talked about caching the metadata as well as the song data. We've done caching. That's all good. Now I wanted to ask you about load balancing. How would you think about load balancing for this particular app?
Yeah, magic, load balancing. It's a little bit of hand wavy here. I think of load balancing. So load balancing commonly is used to, the load balancer's job here really is to make sure that these web servers are not overloaded, so that they're providing good service to the end users, and they're not overloaded. And overloaded can mean many things. Often it's in terms of CPU. So you're getting requests in, lots of requests coming in, and if you're getting lots of requests coming in, then just load balancing these requests across the servers so that there's roughly the same number of requests on each one, assuming they're all equal, would probably also result in the CPU utilization being about equal. I think for this application, I would think about load balancing. I might think about it a little bit differently because we're streaming data. And so I might be instead of using CPU as my load balancing metric to figure out how to distribute the load, I might be looking at possibly network bandwidth. Like because if a particular web server is not doing a lot from a CPU perspective, but if it is IO bound or network bound, meaning it's hitting its limit of its network connection, then I wouldn't want the load balancer to send it more traffic, because it's just going to bog down and you're going to get skips and things like that. So I might make this load balancer aware of multiple metrics, one of them being network, maybe memory for caching, although you can kind of limit that possibly, but maybe not CPU for this purpose. It might be requests outstanding or current streams or something like that. There might be some other metrics, but I would want to make this load balancer maybe a little bit smarter than just a typical request round robin load balancing scheme. So I'm not sure if that's getting at what you're asking.
Yeah, I think that answers my question. Load balancing is not a one-size-fits-all. Mark mentioned looking at different metrics as a way to load balance across different servers, which was a clever approach. Mark was very open about the fact that load balancing isn't an area he's an expert on, and this is okay. It's fine to be honest when you're asked about things that are at the limits of your knowledge. Okay, cool. All right. Are you done with your design, or is there anything else that you want to add?
Yeah, let me think about that. Give me just a moment. I mean, I've way oversimplified this, but I guess I think if I were to also think about this at a global scale, Spotify is a global app, and so it's possible. So replication. I didn't really talk about replication other than to do the math to say, hey, maybe 3x replication. And replication, right? Why do we do this? Well, we do it to make sure that we have data available when there's an outage. So if I were to I might do this, right, to indicate 3 replicas, but that's a little naive. And the same thing for the metadata, of course. But the replicating the data is not just for availability and downtime. It's also, you would want to place those replicas closer to where the users are. And so from a global perspective, you might have music that is more local, like maybe European punk rock is more listened to more in Europe, and maybe BTS is because it's Korean pop, is maybe it's more popular actually in Korea or in Asia. And so you might want to have the replicas of those songs and maybe even the metadata be more locally represented, more locally, so that you can get to it faster. You don't have to cross an ocean to get to the data, and to reach it. So kind of a geo-aware strategy of data placement and possibly replication strategy. That might be a refinement, I think, that I might make to this design to make it just a little bit more performant, effective, et cetera, et cetera. So yeah, does that make sense?
Yeah, I think that's an interesting point to add. It's a good idea to wrap up your answer by referring back to the requirements laid out at the beginning of the interview and confirming that your design meets them. If you have time, it's always nice to think big and take a quick look at the problem from a different dimension that could make it more complex. Mark did this with his geolocation idea. He didn't go into detail, but another interviewer might have explored this further, and it could have opened up a whole new aspect to the design. Overall, an excellent answer from Mark. Yeah, great job, Mark. I think that was a really good approach. How did you feel now looking back, now the interview's over? Let's say you've walked out of the interview room and breathed a big sigh of relief. How are you feeling that it's gone?
I feel pretty good about it. It's it's definitely different being on the other side of things, and I know that I'm sure I missed things, and I'm if people are watching this and wind up scheduling a session with me, I'm happy to take the feedback on some things that I've missed. I'm sure I've missed things, but yeah, it's fun to do this though.
Cool, good stuff. Well, thanks very much, and thanks everyone for watching. Hello, I really hope you found that useful. If you did, you can like and subscribe, and why not come visit us at IGotAnOffer.com. There you can find more videos, useful frameworks and question guides, all completely free. And you can also book expert feedback one-to-one with our coaches from Google, Meta, Amazon, etc. Thank you, and good luck with your interview.